right, greetings AP Calculus students. We have one more section that we need to cover before we take the AP test or get ready for the AP test. And what we're going to do in this last section is we learned yesterday how to find the area between two curves. Now we're going to take those areas and we're going to generate volumes, and we're going to find the volumes of those areas being revolved around an axis. And so we have two methods. One's called the disk method that I'm going to teach you today, and then tomorrow is the washer method that I'll teach you on Friday, and then we'll be done with the new material, and we can then concentrate on our last 3 or 4 weeks getting ready for either AP test. So let's go ahead and start with the disk method. It says if we revolve areas around an axis, we generate volume. So if you take a look at this picture over here, I have some region here, R, and I'm going to take this region and I'm going to revolve it around the x-axis. I'm going to spin it around the x-axis. And if you can visualize this region being spun, think of it's like it's on a spinner and you're twirling it. As you twirl it around, it's going to generate this shaped object, which I don't even know what you would call. And what I want to do in this section is find the volume of that shape. Okay, now, it says if a rectangle is revolved around an axis, which I have here in R, in this beige colored one, if I revolve that around the x-axis, it generates a cylinder. Let me show you that. So here's that rectangle right here that's over there, shaded in here. Here's my rectangle. If I revolve that around the x-axis, this is what I get as a three-dimensional figure. I get this disc-shaped object. Okay, so if you think about, there's my rectangle right here, and if I spin it around the x-axis, it's going to generate a cylinder, kind of like what you see right over here in this tan color on this three-dimensional object. Now, you probably don't remember, but the volume of a cylinder from geometry is pi r squared h. And so if you take a look at the rectangle being revolved, the radius is actually this distance here, which you can see up here they call with an r. So this would be the radius. And then the height of the cylinder, because it's laying on its side, is actually here, which would correspond up here. Now, if you draw these rectangles in your grid, we call the thickness of the rectangle, if you remember, we call that delta x. So the width or the height of the cylinder is delta x, and the height of the rectangle or the radius of the cylinder is going to be, we're just going to call it r. Now, if you can imagine, I'm going to take this region, I'm going to break it up into a whole bunch of rectangles, and I'm going to revolve all those rectangles around the x-axis, and I'm going to generate this shape. I'm going to generate, these cylinders that are a little bit smaller than the previous cylinder to its left. And then that's going to give me an approximate, if I add up all the volumes of those cylinders, it's going to give me approximately the volume of the entire shape. But of course, I want to get the exact volume of that. So I'm going to take and let my rectangles become thinner. As my rectangles become thinner, they get more of them. And so what I'll end up getting is I'll get the volume is equal to the limit as n goes to infinity of sigma k equals 1 to n of this volume formula. And we know that that represents a Riemann sum. And so to find the volume of a solid of revolution, the formula is, it's going to be pi, because my formula has a pi in it. That's just a constant. My limit as n goes to infinity, sigma k equals 1 to n of this expression is going to be an integral. It's going to start at a, it's going to end at b, and it's going to be the formula right here. So your radius is actually this distance here, which is the height of the thing. So we're going to call that big R of x. And then, of course, it's going to be squared because the radius is squared. And then the height, remember, was my delta x. So that's going to become my dx. And so this will give me the volume of a solid of revolution. So it's going to be pi integral a to b of this big R of x, the radius of the volume, squared. And the reason it's squared because you have r squared. The pi is because you have the pi. And then the delta x, which is the height, becomes your dx. Now, this rectangle right here, when you're revolving it, it has to be perpendicular. So the rectangle must be perpendicular to the axis of revolution if you're going to use this formula. And that's really important, and we're going to talk about that in just a second. So the rectangle must be perpendicular to the axis that you're revolving around in order for this formula to work. So let's go ahead and do an example. Do I have my purple pen here? And of course I don't have my purple pen now. I'm looking for it. I guess I don't, so I guess I'm not going to use it. Oh, it's over on my counter. I can grab it later though. All right, so we're going to find it says find the volume of the solid formed by revolving the region around the x-axis. And so here's my region. It's y equals the square root of 9 minus x squared. Again, those of you that have a graphing calculator, you are welcome to type this in your calculator to get a visual of it. Otherwise, this one's already done for you. They already put the rectangle in here. Now, this is going to represent is what I called yesterday. This was that purple double arrow, green double or purple double arrow that I used yesterday. We used to call it green. Now I'm going to call it, well, now I'm calling it a pencil because I don't have my purple pen with me. But this is going to be, again, perpendicular to the axis, revolving around the x-axis. And again, this double arrow line here, or this rectangle, that's going to help you set up your volume integral. So my volume is going to equal pi. Again, they always have a pi in front. That's everyone's going to have a pi because they're always going to be cylinders. Integral. We're going to start here. My double arrow is going to start here. It's going to slide through this region. Remember, it's perpendicular to the axis. It's going to slide through this region. It's going to end here, so it's going to start at 0. It's going to end at 3. And then the big R of x is just the height of the rectangle, or in the case of here, the length of this double arrowed line. So how long is this line? Well, to find the length of this line or to find the height of this rectangle, it's just whatever the top function is minus the bottom function. That's how you get the length of something, top minus bottom. And so in this case, the top is the actual function. The bottom is the x-axis, which is 0. And so therefore, it's just going to be big R of x is just going to be the square root of 9 minus x squared. And then, of course, we have to square it because the formula is squared, and then dx. So really, it's just a function. So when you're revolving around the x-axis, the length of the green double arrow is normally going to just be the function. Again, you could type this in your graphing calculator, but I'm going to ask you to do them. I made them all so you could do them by hand. So pi integral 0 to 3. If I square this, I just get 9 minus x squared dx. And now I'm going to do my antiderivative. Leave the pi in front. Antiderivative is going to be 9x minus 1/3 x cubed. Draw a line from 0 to 3. And this is obviously very simple to calculate. So it's going to be 27. 27 cubed divided by 3 is 9. When you plug in the 0, it just gives you 0. And so it comes out to be, it comes out to just simply be 27 minus 9, which is 18 pi. And that is the correct answer. All right, let's do one more, and then I'm going to be done for today. So my second example, this one you're going to have to draw yourself. Now again, if you want to use your graphing calculator to draw it, I'm fine with that. Otherwise, I tried to make the functions pretty straightforward that you can draw. It says find the volume of the solid generated by revolving the region bounded by the graphs about the given line. So now I'm going to do something other than the x-axis. In this case, I'm going to do y equals 1. I'm just touching kind of briefly this section. There's a lot more different types of problems I could give you. I'm just kind of doing just the basics here. So let's go ahead and draw the picture here. So I'm going to go ahead and draw a nice big picture. Y equals root x. You should know what that looks like. And then I have y equals 1 as a horizontal line at y equals 1. And then x equals 4. X equals 4 is going to be a vertical line at obviously x equals 4. And you want the region bounded by that. So it's this triangular shaped region here. I'm going to shade it in. And now this time we're not revolving around the x-axis. We're going to revolve it around line y equals 1. So I'm going to revolve it here. And so I'm going to take this and I'm going to spin it around. And you can see that I'm going to get some kind of curve shape here. If you want to get a visual, maybe like the nose of an airplane or half of a football or maybe a bullet, the front part of a bullet, that might give you a visual. Again, you don't need to visualize these because we're just trying to find the volume of them. All right, so we got our region drawn. We need to find our where we start and where we end. If I plug 1 in here, I get 1, so this is 1, 1. Obviously, we end here. This is obviously 4, so 4 comma 1. This would be 4 comma 2, though you don't need that point. And then this is really important. And again, I'm going to say this. For us, it's going to be, or I'm going to keep everything be vertical for us, but it could actually go horizontal. But you have to be perpendicular to the axis when you draw in your double arrowed line or your rectangle. And so when I draw that in there, it has to be vertical. And again, I'm going to keep everything vertical for you just to make your life a little easier. All right, so we got it all set up, and now we're ready to write our formula. So my volume is going to equal, don't forget the pi, that's really important, integral. My double arrow is going to slide from 1 to 4. And then the formula, remember, was, go up above, the formula is just this big R of x, the quantity squared. So whatever the length of that rectangle or the length of that line is, that's your big R. That would be the radius. So now again, to find this length, how long is this line going to be? Well, again, to find the length of the line, you take the top function, which is root x, and you subtract the bottom function. So root x, if it was just going to write down root x, that would be from here all the way down to the x-axis, but I'm stopping here at 1. So it's going to be root x minus 1, and of course it's squared dx. So don't forget there's always a pi, and the big R of x, the length of that double arrowed line, the length of that rectangle is always squared, and then the dx on the end. All right, so you have to set it up. Now to do this integral, we're going to have to FOIL that out. So root x times root x is x. Root x times 1 is root x, and I get 2 of them. And it'd be minus, and then root 1 times 1 is 1. And now I'm going to take the antiderivative, put the pi out in front, so I get 1/2 x squared. This is x to the 1/2, so when I add 1, I get 3/2. 2/3 comes in front, makes it 4/3. And then the antiderivative of x is, or 1 is x. Draw a line, 1 to 4. And now we're going to substitute my 4 in. 4 squared is 16. Half of 16 is 8. All right, again, you can use a calculator if you want to, but I'm just going to do it without. So square root of 4 is 8. Cubed is, square root of 4 is 2. Cubed is 8. Times 4 is 32/3. And then plus 4. And then minus, and then obviously 1 is easy. Just get 1/2 minus 4/3 plus 1. Again, you are welcome to use a calculator. I'm totally fine with that, especially since the AP test, you're going to get a calculator. So I get pi times, let's see, 8 plus 4 is 12. 12 would be 36/3. 36/3 minus 32/3 would be 4/3. Over here I get, this would be 3/6. This would be 8/6. This would be 6/6. So 3 minus 8 is -5, plus 6 is 1/6, would be 4/3 minus 1/6. Well, 4/3 is 8/6 minus 1/6 would be 7/6, so 7 pi over 6 would be the correct answer. So again, I'm giving you just really straightforward ones. I'm asking you to do 4 of these for homework, not many. Again, the formula is pretty straightforward. It's simply just pi. Again, don't forget you always have to put pi because when you revolve these, they're all going to be cylinders, and the volume of the cylinder has a pi in it. The integral from where you start to where you end, so your shaded region, just like you're doing the area between curves, start to end. And then this big R of x is just how tall is that rectangle that you're going to revolve, or how tall is that line. And again, to get the length of that line, it's always the top function minus the bottom function. So here the top function is the equation. The bottom function, x-axis, is 0. And for here, the top function is root x. The bottom function is 1. So it would be root x minus 1. If you go around the x-axis, it's pretty much always just the function. All right, in my final example here, we can also revolve regions around, instead of the x-axis or lines parallel to the x-axis, we can revolve them around the y-axis or lines parallel to the y-axis. Now when you do that, for example here, the region R is enclosed by the function f of x equals the square root of 3x, y equals 2, and the y-axis, and it's revolved around the y-axis. Now when you revolve it around the y-axis, then your double arrow has to go horizontal. because your double arrow, remember, must be perpendicular to the axis of revolution. And so if you go around the y-axis or a line parallel to the y-axis, your double arrow is going to go horizontal. It also means that everything has to be in terms of y, because your double arrow is going to slide from top to bottom. It's still going to be the same formula. My volume is going to equal pi integral, but now I'm sliding from 0 up to 2. Those are actually y values. Okay, so we're not going this way. We're not sliding left and right. We're sliding up and down, so they're y values. And then it's going to be the length of the double arrow squared, the radius squared. Well, that's just going to be the function, but the function has to be solved for x. So I'm going to square both sides and divide by 3. So x equals y squared over 3. That's the equation I'm going to use. So it's going to be y squared over 3, and then don't forget to square it, and then it's dy. And again, this is really important that you include the y there. So when you go around the y-axis or lines parallel to the y-axis, your double arrow has to go horizontal. That means you're sliding up and down along the y, so your limits are going to be y values. You're going to have a dy at the end, and then this is super important. Your function must be solved for x. It must be in terms of y. All right, again, to do this one by hand would be pretty simple. It'd be the integral of pi, integral from 0 to 2. I'm just going to square it to get y to the 4th over 9 dy. Do the antiderivative. I'm going to get add 1, y to the 5th, divided by 5 means divided by 45, 0 to 2. And so it's just going to be 32 pi divided by 45, because 2 to the 5th power is 32, and then divided by 45, when you plug in 0, you get 0. And that would be the volume of that solid, which would be some kind of like a, I don't know, like a top shaped figure. Again, you can go around lines other than the y-axis. You can go around parallel to the y-axis. There's my last example right here. The region R enclosed by f of x equals y cubed, or x cubed, excuse me, x equals 2, and the x-axis is revolved around the line y equals, or x equals 2. So I'm going to revolve it around this line. So once again, my double arrow has to go horizontal. So my volume is going to be pi integral. It's going to slide up and down, remember. Remember, those are y's, so it's going to slide from 0 up to 8. And then it's going to be, again, the length of the double arrow here. Because if I revolve it around here, again, you can see it's going to be a disc, again, some kind of a cone type shape here. And now what is the length of the double arrow? Remember, it's always the right function minus the left function. So the right function is going to be 2 minus, now the left function is x cubed, but it's got to be in terms of y, so it's going to be the cube root of y, and then don't forget you got to square it, and then it's dy. Now this one I'm not going to actually do by hand because it'd be kind of messy to do by hand. I mean, you could do it by hand with everything. I'm just going to go ahead and do my calculator here. On the assignment today, some of them I'm allow you to do in a calculator, some of them I want you to do by hand. You can just read the directions there. But when I do in the calculator, I like to type the pi in first because otherwise I forget the pi. So I'm going to do pi. Oops, let me turn it on first. I'm going to do pi, and then math 9, and then it's going to be parentheses 2 minus, the cube root is under math 3, that's easy to remember, x, oops, that's cubed, the cube root must be math 4, it's math 4, excuse me, and it'll be the cube root of x, and then I'm going to square that, and then comma x, comma 0, comma 8, and then close it. And again, I already got the pi there, so I don't have to worry about the pi in the end. Because it's got a cube root there, it takes a little bit of time to figure it out. It's taking really a long time to figure it out this time. There you go. 10.053 would be my answer. All right. So those are discs for you. Again, most of them are going to be around the x-axis or lines parallel to the x-axis. Or in this case, the last two examples are on y-axis or lines parallel to the y-axis. But remember, the formula for a disk is just pi integral from a to b of big R of x or y squared dx. Okay? And that's how you do a disk. Tomorrow we'll learn how to do a washer. Okay? All right, which is just a disk with a hole in it. All right, good luck to you.